Pre-calculus 2.3, day 1. So we are going to be looking at division of polynomials, and then we're going to do it by long division as well as synthetic division. And let's just look at a kind of a concrete example of basic division problem. It's been a while since you've maybe done that by hand. Let's take 29 divided by 3. 3 would go on the outside, 29 goes inside, and then 3 goes into there 7 times, and you have a remainder of 2. So I would say 29 divided by 3 is equal to, oh, I don't know why I wrote 7, sorry. I guess I was thinking 27. 3 goes into 29 9 times, because 3 times 9 is 27. And then you have a remainder of 2. Sorry about that. And so then we would write this as 9 plus the remainder divided by our divisor. So 29 divided by 3 is the same as 9 plus 2/3. It's 9 sets of 3 and with a remainder of 2. So anyways, now if I multiply that equation right there through by 3, I can write 29 is equal to, I can just leave it 3 times the 9. And if I take 3 times 2/3, I just have 2. And I wrote it like that because now we can line that up with this f of x equaling d of x times q of x plus r of x. So in this, the 29 is my dividend. My divisor is 3. My quotient is 9. And then my remainder is 2. That's the one that we know probably the most, the remainder and the divisor. But the dividend is what goes underneath the division symbol, and then the quotient is what you get as you're dividing. And so knowing dividend, divisor, quotient, remainder is something that we would want you to do. And so when I divide this using long division, then what I am going to do is, this is what I'm dividing by, so that is my divisor. This is what I am putting underneath the division symbol. This is my dividend. And so I'm going to write x squared plus x minus 1 and divide that into And so now the key is that I want to match x squared with 6x to the 4th. I want to choose something to multiply x squared by so it becomes 6x to the 4th. And so if I multiply x squared by 6x squared, it will become 6x to the 4th. And I'm going to line that up above the squared term right there. And so now I am going to multiply that 6x squared times all 3 of these and put that in and start my division. So 6x squared times x squared is 6x to the 4th. 6x squared times x is plus 6x cubed. And then I get a minus 6x squared. And then I'm going to draw a line, and I need to subtract. And what I like to do is change the signs and add, because I think it works out better. So I like to change the signs and add. So make it negative, and then make this positive, and then add. Change the signs and add is going to be the same as subtracting. And so I get 0. That's exactly what you want to do, is so you can reduce that power. You want those to cancel. That's why we made them the same, so that when you subtract, they cancel out. And then I get a minus 7x cubed. A minus x plus 6 is plus 5x squared. Then bring down that next term. And start the process all over. I want to match this x squared with this minus 7x cubed. I want to think, what do I need to multiply x squared by to make it a minus 7x cubed? And that would be a minus 7x. And then you are going to take and multiply that negative 7x times each of these terms, getting a minus 7x cubed, a minus 7x squared, and a plus 7x. So I'm just multiplying that minus 7 times each of those. And then I'm going to draw a line. And I need to subtract. That's what you do in division at this point. You subtract. So instead of subtracting, I'm just going to change all these signs. So I'll make this plus, and make this subtraction, and think of addition. And now when I go to add these, I get 0, I get 12x squared, and then 9 minus 7 is plus 2x. Being able to subtract correctly is one of the places where people make mistakes, so be very careful with that. And then I'm going to bring down this minus 3 and start the process all over again. And so I need to figure out, how can I get x squared and 12x squared to match? Well, I just need to multiply by 12. And I'm going to multiply all three terms by 12, getting a 12x squared, a plus 12x, and a minus 12. Draw a line. And now I need to subtract. So in subtracting, instead I can add the opposite. So I'm going to change all the signs, make this positive, and add. And I get 0, 2 minus 12 is a minus 10x. And minus 3 plus 12x is plus 9. I am done because the degree is less than my divisor. The degree of this is 1, is less than the divisor. The degree of the divisor x squared plus x minus 1. The degree of the divisor is 2. The degree of this is 1. So you are done. So this right here is my remainder. And so just like we wrote the 9 plus 2/3, the quotient comes first. So we are saying this division, my answer is going to be my quotient. Oops. And then next you take the 2 and put it over your divisor and use addition. So plus your remainder, which is a minus 10x plus 9, over your divisor. And what you're dividing by is that x squared plus x minus 1. And that is longhand division. And this whole process of being able to multiply and subtract correctly, you have to be careful. There's a lot of opportunities for errors. So be neat, organized as you do that. By the way, it's helpful in your dividend, if it's missing a power, to put a 0 space keeper underneath in your dividend so that you have a spot for each descending power. That can be helpful. And you could, if you need to see some more examples of long division, you can search, do a Google search for videos on long division and kind of watch someone work through some more of those. And they're also available at larsonprecalculus.com and et cetera, et cetera. So example 2, synthetic division. So right here, the divisor is x minus 2. And so a possible root is 2. It's kind of like if I took x minus 2 and said that was a possible 0, that would make it the polynomial equal 0. And if I add 2 to both sides, x equals 2 would be your root. And so it's basically the opposite sign of this is what we're going to use in synthetic division. And so we are going to use 2, and this is how I structure my synthetic division. And this is 2. Notice that this was minus 2, so we're using the opposite sign. And then we're going to take the coefficients of my dividend, and every descending power must be represented. So in synthetic division, every descending power must, so we're starting with cubed. So you need a coefficient for cubed, you need a coefficient for the x squared, and then you need the coefficient of x, and then the minus 5. Here, every descending power, it goes 3, 2, 1, and then 0, so they all are there. I'll give you an example after this where they aren't, so I can further explain that. And then we leave room for a row of numbers. And so the first thing you do in synthetic division is you bring down this first coefficient. They have to be in descending order. And then you take that divisor, that possible root, and multiply by that number and put it underneath the next one. So 2 times 2 is 4. Then you add negative 8 and 4. You just bring it down and you get a negative 4. And now you are going to multiply that negative 4 times the 2 and put it right here, getting a negative 8. And then you add 13 and a negative 8 is 5. And then this last piece is going to end up being your remainder, but you start with the same process. Oops. And you're going to take 2 times that 5 and put it right here, and then add. Since this is not 0, 2 is not a root, so 5 is the remainder. 5 is your remainder. So 5 is my remainder since it's not 0. 2 isn't a root, but that still helps me because this right here gives me the coefficients of a quotient of 1 less degree. And that is going to be my quotient. And so what this is going to be, it was x cubed, so this is going to be a 2x squared minus 4x plus 5. So it's 1 degree less. And then my remainder is 5, and you put that over your divisor, and what you were dividing by was the x minus 2. And that is your answer for the division using synthetic. Now I said I'd give you another example about that whole what if you need a 0 placekeeper kind of thing. And so an example is 2x cubed plus 13x minus 5. And if we have that divided by x minus 4. So since it's x minus 4, we'll use a positive 4. And we have an x cubed coefficient is 2, but we have no x squared coefficient, so we need to put a 0 placekeeper. If you don't, your synthetic division will not work. It'll all be wrong. Then we have x, and then we have our constant. So every decreasing, if it's cubed, you're going to have 4 of them. So to the third, to the second, to the first, and to the 0th, every descending power needs to be represented. Then bring down your 2, multiply times 4 is 8, and add. 0 plus 8 is 8. 8 times 4 is 32, and add. And 45 times 5 is going to be 180. And then that remainder is going to be 175. And so we would get 2x squared plus 8x, 8x plus 45, and then put that remainder over your divisor of x minus 4. And there's another example of synthetic division. And we will reserve examples 4 and 5, I believe, for day 2. Oh, actually, I'm sorry. This is all in one day. I forgot we're going to combine them. Silly me. Okay, so that was a different year. So this is your entire 2.3. It's not just day 1. I kind of forgot about that for a moment. All right, so the remainder and the factor theorem. Use synthetic division and the remainder theorem to find f of 2, given it's this negative x cubed plus 5x minus 7. So notice what we're doing is synthetic division on this. And we've got the negative 1, the 0, the 5, and the negative 7 because we don't have an x squared. So we have to have that. And in this case, we want to know if 2 is a root. So is 2 a root? Meaning, is x minus 2 a factor? And so we do the synthetic division, and right here we have a remainder, and it's not 0, so 2 is not a root. And the value of the remainder is the value of this function. So the remainder theorem just says, if you do synthetic division, whatever you get here is the value of this. So f of 2 is negative 5. And notice that this is a positive 2 here, and this is a positive 2 there. So that remainder is that value. And that's using the remainder theorem. Now, if I divide in part B by x minus 2, notice we're using a positive 2 here, the opposite sign here. And notice that this comes out to be 0. That means 2 is a root. And therefore, x minus 2 is a factor. Because it means f of 2 is 0. And when that remainder comes out to 0, 2 is a root, and x minus it is a factor. And so that's what all of this is saying. A polynomial has a factor if and only if f of k is 0. So right here we're saying f of 2 is 0, so x minus 2 is a factor. So with that being said, we're going to use this idea, if you get a 0, that 2 is a root. We're going to use that in example 5. So it says, show that x minus 3 and x plus 2 are factors of this polynomial, and then factor the polynomial completely. So we're already telling you they are factors. So what we're going to do is we're going to use synthetic division, and we're going to use this first one, use 3, and then we have the coefficients, 1x to the 4th, 2x cubed, minus 7x squared, minus 20, and minus 12. And we're going to do synthetic division. And so as I go through this, then if I bring down the 1, multiply by 3, add, I have 5, multiply, 3 times 5 is 15, and add is 8. 3 times 8 is 24. And if I add, I have 4. 4 times 3 is 12. And if I add, I have 0. So that means 3 is a root, and x minus 3 is a factor. And then these are the coefficients of a polynomial of 1 degree less. And so what I'm going to do is, now I am also told x plus 2 is a factor. So I am just going to use those as they are and continue doing synthetic division with knowing this would be a 1x to the cubed plus 5x squared plus 8x plus 4, because those are coefficients of a polynomial of 1 degree less. And I can just continue, bring down your 1, multiply by -2, add, -2 times 3 is a -6, add, -2 times 2 is -4, and add, and I get 0 again. That means -2 is a root, and x plus 2 is a factor. And then these are coefficients of a polynomial of 2 degrees less than what we started with, because we've done that synthetic division twice. So what I have right now is f of x was x to the 4th plus 2x cubed minus 7x squared minus 20x minus 12. And now what I know is if I want to factor this, I know that one factor is x minus 3. The other factor is x plus 2 because they had remainders of 0. And what is left over, I'm going to use this. Remember, I've divided twice, so that is x squared plus 3x plus 2. But it factors to that. And so by having a polynomial of degree 4, but given 2 factors and using synthetic division, I can get it down to quadratic, and then we have other ways of figuring out the zeros, the roots of that. And in this case, it actually factors into x plus 2, x plus 1. And so I'm going to write x minus 3. The repeated factors, I'm going to go ahead and combine them to the second power. I want you to see that. And so I have now factored this completely. And actually, they didn't ask for the remaining zeros, so I was thinking we were going to go for zeros. I should have reread the problem. They just said factor the polynomial completely. And so my end answer is not finding the zeros, but just factoring it. And so there is my final answer.